Hello, and welcome to Debugging Downtime. I'm your host, Z Spencer. In today's episode, Jennifer 2, Jackson Latka, and I wrap up stabilizing Notably's database infrastructure. In our last episode, we added a read replica. This ensures that only a portion of API requests time out in the event of a single database node lock. In this episode, we set up a third database instance to spread out the negative effects of a read lock even further. To keep our costs low, we scaled down the CPU and memory requirements for each database node. Debugging Downtime is supported by viewers like you. You can show your support by subscribing to our channel, liking our videos, tweeting with the Debugging Downtime or Real World Code hashtags, or buying a season pass on our website, weeklyhere.com. Once we reach $2,000 in sales, we will hire a video editor to clean up our uncut episodes, remove dead space, plug rabbit holes, and highlight these diamonds in the rough.
All right. So, welcome everyone. Today we are going to I think we can make Notably profitable today. I think. So,
let's do it.
I mean, it's not a promise.
Let's do it. I'm ready.
All right. Okay. So, my understanding is right now the majority of your expenses are tied up in AWS costs, right? Like thousands of dollars in AWS. Is that correct?
Correct.
Okay. So, I think my plan is going to be we evaluate the CPU usage of the RDS instances, and I'm take a kind of look at that, and then basically fan out to 4 smaller instances, or maybe so that we have 1 primary and 2 or 3 read replicas. Jennifer, how many read replicas make sense? I know there's rules about this in computation.
I don't actually know the answer to that. I kind of feel like what we should do is see how it's been behaving with 1 read replica and go from there.
Yeah, that makes sense. And Jackson, you mentioned that everything fell apart yesterday for a couple of minutes. How frequently has that been happening? And
Well, to back up, I wouldn't say everything fell apart. I would say that things have been drastically improved since we implemented the read replica, to the point that we're having timeouts, but those timeouts are typically just like a few minutes per day or every other day. So, and typically the system self-recovers, so I haven't had to reboot. I don't think I've had to reboot once since the read replica.
So I'm going to consider that a giant win. And next step is to get another giant win here, which is no timeouts, but also not super expensive. So I'm on board with you, Jennifer, around let's look at what's really happening first.
Yeah. Though this is not a rhetorical question. How does adding a second read replica make it less expensive?
Yes. So the pricing model for AWS is pretty interesting in that if we set up reserved instances are like 30% cheaper than non-reserved instances. So my theory is we can set up 2 read replicas in reserved instances land, or potentially 3. Maybe we'd have to start a brand new system. Let's not do that. Let's not think about reserved instances yet. But my theory is that because the performance characteristics of AWS RDS are basically aligned around disk size, and disk size is pretty inexpensive. Like how much per terabyte for AWS? It's like 2 cents, 2.5 cents. Yeah, it's like
for a month.
Per month, right? And so most of the disks.
Wait, that was per gig.
No, sorry. For the first, it's 0.2 cents. So how do you do this math? I need a calculator.
Multiply by 1,000. It's 1,024, but just call it 1,000.
Yeah. So 1,000 times 0.02 is $20 a month for terabyte. Ish.
Sure. I mean, it's less than 200.
Okay,
yes.
Fine.
Yes.
1,000 times 0.02. 20. Yeah.
Yes.
So we're looking at about $20 a month per terabyte, and we only need to back up the primary. So if we have a single terabyte of disk usage, that's a terabyte of space. It's $20 a month. And then each read replica is another $20 a month for that. And then if you look at the pricing for EC2, whoops, not EC23, and we look at the current RDS configuration, we're looking at M4 X larges, which are giant.
Those are expensive.
And yes, and it's not that they're super expensive. I mean, they are pretty expensive, but if we look at M2 X large, M2 dot, really? Did I read that wrong? M4 X large. M4. Where did it go? There it is. M4.X large. So this is 20 cents an hour. So 0.2 times 60 times 24 times 30 is about $86. No, wait. Oh, sorry. 24 hours. $144 a month per instance at this size.
Right. And how many do we have?
We have 2 right now. So where did my math go?
Because they need to be the same size.
Because they do need to be the same size.
So we could drop from $300 to closer to $60 a month.
I think so. Yeah. So if we look at what the DB and the read replica's CPU and memory performance characteristics are, we're barely scratching the CPU, right? If we look at the monitoring, this is the read replica, right? I don't want to import my bookmarks, thank you. Yeah, like we're peaking out at like 10%, and our memory, like, we're barely scratching the surface. Let's go to the last 2 weeks.
Is that the read?
So this is CPU. We're barely hitting 2%, and this is not read. This is primary.
That is not the read. So that one barely has anything hitting it, which is confusing to me. So I think just to back up and help me add some clarity here is, it seems to me like we had this primary database that everything was hitting, right? All the reads, all the writes. And then we added this read replica. And it seems to me that we kind of just shifted everything over to the read replica, reads and writes.
So we didn't shift the writes to the read replica. What was happening is IOPS are distinct from updates. And Jennifer, you said you wanted to talk real quick. So I want to see if you have an insight into that before I answer Jackson's questions, because you said something.
No, go ahead. And I was like, Jackson said a thing. Did you hear him?
Okay. Yes. All right. So the way I would approach it is that if we think about select statements, sometimes select statements in SQL cause writes to the database because they have to write a temporary table. So what they do, writes to the hard disk because they have to create a temporary table. So what you might do is you might do a select, and you do one query inside of your select that's like, hey, get me all of the, super awesome ponies. And then it's going to write that temporary table to the disk. And then you're going to do another read to say, and now from these super awesome ponies, do this other operation. And so even though it's technically a select query that is going across the wire, that query is causing writes. Does that answer your question, Jackson?
I think so. But when I look at the stats and when I compare the side-by-side in the monitoring between the read and the primary, it basically looks like we've shifted all activity, or not all activity, but 90% plus activity from the primary to the read.
Yes, because your system is 90% reading. It's not like you get, for every note moment that's posted denotably, I would guess you have at least 8 to 10 reads of that moment.
Yeah, that makes sense. But I guess I was thinking about it as like we were almost splitting up the writes and the reads. So the writes would come into the primary and the read would come off of the read replica.
Yes.
So
and that's what's happening. So
except we're still seeing a lot of writes on the read.
We're seeing a lot of IOPS on the read.
Okay.
We're not seeing a lot of, so is this 2 months too? Let's change this to 2 weeks. So we're seeing a lot of write IOPS, but we're not seeing a lot of updates. So the SQL query that's being sent is a create or an update, and when a create or update is sent, it's coming here to notably this primary system. And when a select comes in, it comes in here, and those selects can cause writes to the disk, given my previous the previous thing I was telling you about.
Mm-hmm.
Does that feel less fuzzy now?
Yes, it does. Thanks.
So what I would like us to do is I would like us to start by dropping this down to maybe a third for the primary. So we go from an M4 extra large, which is 4 CPUs, 16 gigs. Maybe you should go half.
Start with half.
Yeah, let's go to M4 large and see how that goes. I think we could probably...
Yeah, where are we aiming?
I think we're aiming for... I mean, T2 is still, like, that's still about the same price, so it's not going to save you that much money.
It's the T2 medium that...
I think we want an M... I think we want an M series, because M's are designed for... M's... From my understanding, the T series is for... they tend to be higher in CPU and lower in memory. So like,
and the M series are for memory usage ones.
Yes, like the price per gig in RAM is what we really want to be looking at here. So 16 gigs of RAM at 20 cents an hour versus 16 gigs of RAM at 17 cents an hour, 16 gigs of RAM at 19 cents an hour, 16 gig of RAM at 18% per hour. What else? 16 gig. No, that's 23 cents an hour. Yeah, so I wonder if there's like a memory optimized, because the compute optimized, yeah, that's 34 cents an hour. Here we go.
Memory optimized.
Yeah. So 16 gig, 12 cents an hour. 128 gigs? Holy crap. Am I reading that wrong? Wait, what are these headers?
What headers?
The
you mean of the column.
ECU. So memory, let's keep scrolling. So let's see what else has 16 gigs of RAM. 12 cents. 11 cents. I don't know. I'm not seeing anything that shouts out at me as inexpensive from a RAM perspective.
It seems like going from that M4 large to the M4 medium is going to be the only step we need to take.
Are we XL now, though?
Yeah, we're XL. So it'd be from M4 XL. Where did it go?
To M4 large.
Yeah,
that's right. There's no M4 medium.
And so what that means is our price will go from 0.2 times, so 2 times 0.2. So we'll go from $288 a month to, let's say, 3 times 0.1 to $216 a month. And it gives us a third server so that if one of them gets overloaded, we are less at risk. Or we could probably leave it at 2 and just half it, because it's not that the issue isn't CPU and memory, it is IOPS. And
that should be something easy for Jackson to scale up, right? To go from like 1 to 2 is kind of like you want to make sure you know what you're doing, but 2 to 3 feels like it's a safe operation for Jackson to take himself or for his team to take.
Yes and no. Right now, the way we've got everything set up is it's not going through a load balancer, so we would have to add it to the Makuru configuration for each system, but that's not a big deal. So what I would like to do, so if 1,000 terabytes is $20, or sorry, so the other thing to keep in mind is each of these instances is 500 gigs. So if we go to 3 instances at 500 gigs, that's $30 a month. But if we go to 3 instances at a terabyte, that's $60 a month. Or even a terabyte at 2 instances, that's $40 a month. So I would like us to bump up the disk for the server as we bring down the CPU. And I think that's the right trade-off to make from a price to performance perspective. Jackson, what do you think about that?
Yeah, that makes total sense.
Cool.
Wait, hang on. Why do we need to bump up the disk?
Because the way that IOPS work, so IOPS per terabyte.
Oh, because you're worried about
AWS.
IOPS.
Yes. So
Okay.
Elastic Block Store.
Wait,
They.
because you're worried about IOPS, which means you need to, if you only drop the processor without moving up the disk space, that's going to have a much more negative impact. I am caught up now.
Yes. So if we increase our IOPS, if we increase our volume from whatever to get to this 16,000 terabytes. Oh, so they're 10 cents a gig per month. So what is 1,000 times 0.1?
100.
Okay, so that does change the price to $200 a month for storage. Which is not the same number we were talking about.
Yeah.
We could look into.
Should we look at the usage and see how much we need to increase anything?
Okay, yeah, I get that. So what you're saying is we might not even need to increase now that we have this second read replica.
Yeah.
But we are seeing stuff falling over still, and that tells me that. So like monitoring. This is, which one is this? This is notably DB. This is read. So this is the last 2 weeks, and this is, I don't see a plateau on the IOPS or in either case. So it might be that the locking is. It might be that the locking is caused by. It might be that the read replica got locked for a second, and that's what caused the 5 minutes. And so adding a third instance does make sense. I don't know. What do you think?
Can you go back to the list of services that we have right now? I'm trying to hold in my head and having trouble with what we intend to change.
So we have notably DB read, which is getting some decent, like not a ton, but a little bit of CPU usage, and notably DB, which is getting almost no CPU usage because it's literally just a write mechanism. And I'm suggesting that we drop these down from M4 larges to something smaller.
From XL to L.
Right. Yeah, but to be honest, we might. So the amount of memory we're using is like 5 gigs. Right. Yeah, these are 6.
Is that 10? 10 gigs?
If we call it 15,000 megs, then wouldn't that be about 15 gigs?
Yeah, I think we're pushing pretty close to 16 there, right?
No, this is the freeable memory. This is the memory that the system doesn't need.
Oh, opposite. Okay.
Yeah. So this is the space this is the amount of space we're using. We're using about a third of the memory at any given moment. So it's possible that we could even dump it down to something that's, well, no. If we're using a third of 16, then we kind of want to stay at 8 gigs.
How hard is it to switch back?
I don't know.
What I'm wondering is, I guess we could try that right now. What I'm wondering is, could we drop the 2 XLs 2 larges, and then Jackson hangs around through his evening, sees if anything falls over, immediately switches one of them back to an XL, and sees if it fixes everything possibly with a restart.
I think so. So we get
downtime each time we do that, though, right? I mean, of course, anytime we restart the database. So ideally, we're not doing that, but if it's going to ultimately get us to the right place where we need to be and save money.
I mean, ideally, the way your system would be architected is that writes would just queue up and reads would, go to the read replica. And we'd have enough read replicas that when that read replica goes down, it's not a big deal. But I don't think we've got that set up in your system yet. So what I think we should do is drop the read replica first so that we don't lose any writes and see how that goes.
Can we do that? Will it let us do that?
I think so.
Because then they're going to be different sizes.
But so the instance size matters much less than the disk size, because the way that they do read replication is they basically give you, oh, cool, and it goes through the maintenance window.
Oh, nice.
So, okay, so Jackson, what if we turn on maintenance mode for Heroku, wait for the queue to clear down, and then downgrade the read replica and the production site to a smaller CPU instance, and trying to figure out a way to make this save you money. Because
without being risky, because the easy way would be downgrade them both and see if it falls over.
Mm-hmm.
But then that's risky to your users.
And I still don't quite understand why the third replica or the second replica is going to help out here.
Yeah,
is it balancing the load between the two?
So the way Maruko works is in the event. What is the name of the thing we use? The way Makora. No, I'm not logged in. I thought I was still logged in. And let me. Oh God. Arrangement. There we go. I just need to get my password. GitHub. Oops, two-factor auth. Give me a second. One, 206. All right, so what is this library called?
Makora.
Makora.
Can you move your screen back up?
What do you mean?
I can't see below password on sign into GitHub.
Oh.
No, I can't see your screen.
Yeah, it probably screwed everything up when I rearranged this place. All right, so Makara read replica failover.
Makora. Oh, it is Makara. Never mind.
So, my understanding is that if we have multiple readers, then it will filter out readers that are failing. So if your database starts getting locked and stuff is getting timed out, it will start sending connections to the non-locked database. So if we have two read replicas and one primary, then theoretically that gives us a second read replica to hit when one of the read replicas gets locked.
So it's a $20 a month insurance policy?
Well, it's not a $20 a month insurance policy, because what was the pricing? So
It's 10
if
cents.
we have 500 times 10 cents times 3, that's $200 for the database server. And if we do 10 cents times 3 times 24 times 30, that's $216 a month for the processor and memory. So the disk would be $200 and the processor and memory would be $216. So all of your database costs would be about $420 per month with 3 instances on the database. Now, it's entirely possible that the way we're reading this chart, this freeable memory chart, where'd it go? Is horribly wrong.
16.
Yeah, because it's like, it looks like we're really only using 2 gigs of RAM.
So really, IOPS seem to be our only limiting factor at this point. But if it's not CPU and it's not the freeable memory,
Exactly.
or it's not memory.
Yes. And so theoretically, our read replicas, we might even be able to dump down from 10 cents to 4 cents, 4.6 cents. If we dump them down from 8 gigs to 4 gig.
Now, by moving away from, is that still in the M class, or is that moving to a different type of
It's a T class.
database?
T2. Yeah, these are just their general compute instances.
I mean, are we going to see a performance hit on just everything being slower?
No, your CPU is not being touched. The thing that is the constraint, because like there's three resources in any computer, right? There's processor, there's network, or there's 4. There's processor, there's network, there's disk, and there is memory. And right now the constraint is purely disk from what we can tell. So theoretically, if we pick some super tiny memory optimized instances, which they don't exist, but if we pick some, because it's not like your database is huge, it clearly fits what your current index list fits into. It fits into like 2 gigs of RAM. So a 4 gigs of RAM is probably enough. And the CPU it's easy peasy, right? Like core is going up to 10% at one time. So that could easily be quartered. And read is going up to 20%. But if we double the amount of read replicas, then we can cut that in quarters too.
Wait, this is an hour of time. Can we expand this to? Yeah, great. Thank you.
Let me double. God damn it! Why does it keep changing it? I don't care about the last hour. All right. So we're really only peaking up at 2-ish% on primary, which tells me you are way overspending here.
Yeah, but primary is not. I mean, we're higher on read, and they need to be the same.
No. The disk needs to be the same.
Okay.
The EC2 instance type does not, because what happens, the way that they do like recovery is they replace the hard disk of the machine with the hard disk from the primary. Okay. And so if you need to spin up a new read replica, it has to be the same size because the primary's hard disk is what's getting distributed over there. But the CPU doesn't matter.
Okay.
So I would even bet that if we dropped your CPU, if we look at this pricing table, we could probably like get you down to T3 mediums for everything, which would be 3 instances at 5 cents an hour times 24 times 30. That gets you down to $100 a month in instance costs while improving your reliability because you have another instance.
Mm-hmm. And are these all the same type of disks? Like, are they all SSDs? Are they all, I mean, are we dealing with the same type of stuff here as far as hardware is concerned?
They're all EBS. And we're not using any provisioned IOPS, and we're not using any SSDs, so that should be purely dependent on the disk. Now, network-wise, I mean, I don't think network really matters for you. Like, I doubt you're getting gigabytes of data being sent back and forth in the database layer. You are at the S3 layer, but that's way different. So want to do this?
If you two think that's the right level to jump to, then I'm all for it. I think it sounds right to me.
Z, before you do it, can we go back to that list of servers and talk through what we're going to do?
Yes. Let me open Atom first. How about that way we can actually, not only talk but type?
Yes.
And get a list of things that's going on. Whoopsies. All right, where's my Scratch file? Okay. So we have primary, which is peaks at how many percent? If we're at here, first this is read.
Let's read.
Peaks at 3% CPU. And then what's the memory usage it's at? Let's read. I'm just going to close a few of these. It looks like it's peaking. This is tough. I don't trust this graph. Because I think it's 16 gigs. And it's saying that it can free up 11 gigs at pretty much any time, which tells me that it needs 5-ish gigs. So we need this to stay at we need this to stay at a 8 gig.
At least 8, yeah.
Okay. Read peaks at, let's say, 15% CPU, and
okay, but when you click into that CPU, when I look at the last 2-week range, it shoots up to like 60, 65.
For the read replica, right?
Yep.
Yeah, so when you have 2 of these, then so like the CPU is processing as fast as requests come in, right? Like it's just going as quick as it can. So if you have 2 of these, then you can expect that this is going to drop down to about, the peak is going to hit about 30%.
Okay.
So the maximum utilization, the maximum utilization is hitting 60, but we would expect the maximum utilization to go to 30 when we have 2. 6% CPU. And let's look at freeable memory, statistic, minimum. This is interesting. The freeable memory, so 16-ish gigs total, and it's able to free up 11. I really want to try bringing it down to 4 gigs when we do. I don't know.
Do you know what that spike is? Was that a reboot or?
I'm guessing. So this is.
What time is that?
It's
4
midnight-ish
a.m.
UTC.
UTC. 4 a.m. UTC, so that would have been like 10 p.m. Eastern, 11 p.m. Eastern.
So what's happening at that point, I think, is that's when we have our rake task for print order processing.
But the thing is, it's giving you a bunch of memory back.
It just finished it, right? Maybe it just finished it.
It just finished it. Say it again.
Oh, I'm wondering if 4:14 UTC is when it finishes the rake task and cleans up a little bit, or can do a little bit more.
what I'm looking at here is that I took a note on Sunday, February 24th, 18:13 to 18:18 is when we had timeouts, and the hourly scheduled task for rake print order processing ran at 18:10. This was scheduled at 18:10.
Okay.
And that's the one that typically, I would say that particular job precedes most of these timeouts. Like that's the one that's doing it. And I have a theory on why, but I can hold off on that.
Gotcha.
Z, can you also write down what kind of AWS instances we're using? Thank you.
Primary M4.L. That is exactly what I wanted to type. Thank you.
What a helpful robot.
1 M4.L read 2 M4.L at 500 gig at 500 gig.
I'm sorry, Z, above where you say 500 gig, can you remove that space? Line 2 and 3? Between
What
500
space?
500 gigabyte.
Oh,
Yes,
sure.
thank you. Thank you.
So persnickety.
It's hard to do pattern matching when you. Thank you.
Whatever. All right, so what we're thinking is we add a second read replica, we drop all the instances size in half. This means that you cut your CPU prices by about 50%, but you increase your disk prices by about 33%. So your disk prices are currently 500 times 0.1 times 2.
What's the times 2 from?
Because it's 2 instances, and so each EBS volume is 10 cents a piece. Per month. So that is $200 so that would be, currently it is $100 a month.
Right, this is disk. I'm back.
And then CPU mem prices are X larges are, if we do 2, so their X larges are 10 cents a month. Or sorry, 10 cents an hour. So, and we got 2 of those. And so we're looking at about $144 a month. Where did it go? There it is. 0.1 times 2 times 24 times 30 equals 44. So if we do this, then our disk prices go 500 times 0.1 times 3 equals 150. Our CPU and mem go to, oh geez, 0.1 times 2 times, or sorry, times 24 times 30 times 3. Yeah, I'm going to switch these to put our amounts at the outside. Like that.
Is line 6 times 2 or times 3?
Oops. Yep, you're right.
Thank you.
Times 24 times 30 times 3. And what does this become?
Wait, where did the 0.1 for that come from?
Oh, sorry. Let's double check our pricing. So it's an M4 large is
10 cents.
Oh, 10 cents. Yeah, so this should actually be 20 cents. And this should be 0.1. So let's do the math correctly here. Of course, I want to know about Second Chronicles. $288 a month.
And that's
and
144. Oh wait, no, it's not.
144. This is 216. So we shift.
Did I see
That's not a
EC2
savings.
in that? Can you switch back to that price sheet real quick?
Give me 2 seconds to finish what I'm doing. So the total is 388, and the total is 366. So we saved $12, but I'm willing to bet this stops all the timeouts. And I'm also willing to bet that we'll be able to step this down to a 5 cents per hour instance. And especially this one. Which would
be what? The T3?
Which would be the...
So, okay, up here in your URL, why are we looking at EC2?
EC2 is the pricing for the instances. RDS,
Okay, so...
RDS is just like an orchestration layer on top of EC2.
Okay. But what we have currently, we're dealing with the pricing for RDS.
No,
right?
no.
Postgres.
So here, let's open a new tab, AWS RDS pricing. So the way Amazon kind of designs their pricing model, which makes a ton of sense, is they don't charge you for, I mean, they don't really charge you for the instance prices independently. Oh no, never mind, they do. They're different. Its M4X large is 36 cents. Good catch, Jackson. I was wrong. Database storage. And this is 12 cents. And then backup storage. I think that's what's at S. Okay, that's pricing.
Can we redo the pricing and write down a little legend for ourselves of what each thing is?
Sure. I don't know what each thing is. So
for
wait a second.
example, what is 0.1?
Oh, you want to turn this into code. So, 2 instances at db.m4.xl equals 36 cents an hour.
If you take out everything, yep, that's great.
Yeah, I'm getting there. I'm just slow. And then
you're doing fine.
Database storage. And we're all in US East, right? That's what your instances are all in?
I believe so.
Okay, so 13 cents per gig per month.
I didn't know US East was in Ohio these days.
Yeah, I think it's Ohio or Virginia.
Yeah.
You have the choice.
All right. So this is actually 0.365 an hour times 2.
Mm-hmm.
Or sorry, times 0.125 per month.
Yes.
And this is really 365 times 24 times 30 times 2.
Yes.
And now I need to do that math again because I was horribly wrong.
That's all right. Jackson saved us.
Thank you, Jackson.
Sure thing.
This is why we pair. All right. You're probably looking at the numbers and like, this does not make sense based upon the information that you have gathered. $5.25. 6. Woo! Equals
650.
60. Does that look
Three-
more like the bill you're seeing, Jackson?
Yes, but I have to say that the cost explorer is really hard to understand. And yeah, I mean, in general, we're paying like upwards of $1,800 a month.
1,800? Where's the
S3.
Where's everything else? Oh, okay.
Yeah, we'll have to talk about a migration strategy to get your archives onto Glacier or something like that.
Yeah, that's a discussion for sure, but we do access old
today.
stuff all the time. That's kind of the challenge.
All right, let's do the M4.large
Yes.
and get both DB and separate.
So that is 18 cents. I'm just going to move the pricing up above currently. Does that sound reasonable?
Okay. Yes, that sounds great.
And I'm going to make this a subheading. And then I'm going to make this a subheading. Whew. So 18 an hour. So I can replace this, drop it here. Nope. That needs to be this. Right? Because that's the disk space.
Yes, that's disk space.
All right. So the disk
that
price
should increase.
Yeah, and it's 13 cents a gig ish per EBS instance. And then
wait, that's
CPU
the XL.
Yep, thank you. And this is the CPU and memory is 18 cents an hour for the M4. So go back to our Googles because I don't know how to soft launch it.
Times 3. It's going to be 186, 8187.
Okay, and then
bottom line 19. You need
yes,
to recalculate.
So we were spending about $380 per month on RDS. And then it jumped to $492 in February because half of that month had a read replica.
Yes.
Give or take.
Whereas the
third of the month.
That tracks with what we're seeing here then.
Okay. So we're actually, as far as profitability, we're actually going further away from that than where we were a month ago, but the service will be up.
The service will be up. All right, so what's 187 plus 393?
400. Wait, 500 and something? 520, maybe?
I want to say 580. Yeah, that was good. All right, so we do wind up saving about $70 a month with this change.
What? That's spending more, right?
No, because the total is 650, 525 plus 125, versus 187 plus 393.
Yes.
So we can apply this single change to the infrastructure, save you about $70 a month from what you would have spent if we hadn't applied this change, and increase your reliability and performance, hopefully without, and also increase your reliability and performance, assuming that my read of us needing 8 gigs is correct in the memory perspective. And I'm willing to bet, not this instance, but maybe our next session, if we really want to, I'm willing to bet we could drop that in half again once we see the characteristics of the 3 servers.
And that would be going to something that has 4 gigs of memory.
Yeah.
Like one of the T3s, T2s.
Something like that, yeah.
Okay.
All right. Does this give you enough confidence that we can move forward, Jennifer?
Yes. Jackson?
Yeah.
All right. Do you want to turn on maintenance mode?
Yep.
And turn off the workers. You don't have to turn off the web systems, just the workers. And let me know when you hit that point. I'm going to grab some water because I am hella thirsty. I forgot to refill my water before I joined. Good shit. All right. This is super terrifying. All right, so let's okay, so first what we're going to do is we are going to go to RDS and we are going to edit our database instances, and we are going to modify this to a DB-M4 large for notably DB. I'm so afraid. It's gonna be fine. Do we want to bump this up to 500 gigs just for kicks and giggles, or no?
No.
Would that affect IOPS?
It would give us a little bit more IOPS.
It seems like we don't need them based on adding a whole nother replica.
I'm good with that. I think that's valid. Continue. Apply immediately. All right, so it should be in a spot where it is modifying itself. Yep. And then once it comes back up, I think we can do the same thing for the read replica. And then
Weren't you saying that we could, if we kept the disk size the same, we could actually drop primary quite a bit more?
I think that is true.
Since we're using such little amount of CPU and memory.
I think that is true. If you want, we can do that. We'd have to start over. Not start over, but we'd have to restart the modification process. But that's super easy to do. Oh, no, wait. The memory is the important part. That's the constraint.
Right.
What is that you want to...
Yeah.
Sorry, are we changing the plan or sticking with the original plan?
Sticking with it for now.
Okay. All right, so that means we want to do the read replica next, right?
I totally just did that because I go fast.
That's all right. I got distracted pouring myself more tea.
Mm-hmm. So yeah,
wait, sorry,
I think.
Can you, wait. I'm sorry. Can you go back to the read and just show me that it's on a M4 large? Okay, great. Thank you.
It is modifying itself. Yeah. And then, how do you provision a new read replica? Oh, can I just do that? Wait, which? Oh yeah, we're in East 1.
I thought the others were in Ohio.
Oh yeah, that's a good point. No, we're in North Virginia right now.
Okay.
There's US East 1 versus US East 2. So our pricing might be slightly off because they are ever so slightly differently priced.
I don't expect it to be particularly significantly differently priced.
Did we?
Mm-hmm.
Yes, we encrypted last time, and M4 large, no multi-AV, SSD, notably DB read 2. Enable enhanced monitoring. Is that the one? And then maintenance. Yes. Cool. Oh, I'm not allowed to do this.
Okay. I'm on it. I'm gonna pop it open here.
And in the meantime, Jennifer, we need to go to our Makara config, or our database.yaml rather, and be like, what is our secondary read replica URL?
Publicly accessible, yes. Encryption, yes. DBM4 large. 8 gigs of RAM. General purpose SSD. Read replica of notably DB, calling it notably. Is it notably DB read 2?
Yes. Read dash number 2.
Okay, notably dash DB dash read dash numeral 2.
And then I'm going to send this to you in chat because what you'll need to do when it gives you, what you'll need to do when it gets you the, is my, you know what, I'm just going to send it to notably.slack.com. Because it's gonna give you a URL. For notably.
Oh, we can't do it until the modification is complete.
That makes sense.
Makes sense.
Do you could you create? I think we want to create one for staging too, right?
Yeah. Should we?
So the thing I'm worried about is I don't trust Makara's nil checking. If we have to put if we put this in the configuration and then Makara throws a fit, like, actually no, we don't have to because
staging has something different.
Staging is using a different configuration file. Never mind, we don't have to do that.
Okay, it's still modifying. Now it's available. Cool.
And that way, once we do this deploy, theoretically, it will start hitting the read replica itself. Oops. I want to move this to the right and do tmux attach. There we go. Go. Where's our git ignore file? Boop. I'm just gonna add scratch to that so it doesn't keep trying to commit it. And now, what did we do?
Add secondary read replica for Makara. Sure.
Experiencing some
timeouts.
We believe this is caused by the read replica locking, and since there is no other read replica, Makara doesn't have a place to direct new connections or to fail over existing connections that won't overload primary. Reasonable commit?
Yep.
Push it. Nope. Bum ba 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 ba. Nope. Da 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 bum ba da da dun dun da 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 dun da da. Okay, I'll stop. I'm sorry.
Can we go back to Adam and look at Scratch? And is there anything else we need to change? We did the primary, we did the read. Jackson is making the second read.
Yep, that's
I
creating.
think that's it.
Yeah.
I'm wondering if it would be at all useful to run one of those expensive rig tasks when things come back up and we go out of maintenance mode.
Possibly. What I've come to discover is that those rig tasks are only expensive when there's also high usage, because that's when it's actually raking up all the moments.
Yeah. So we could run it now and see if it falls over on its own, but that doesn't seem very likely.
Yeah, I would prefer not to do that.
Okay, that sounds fine.
But it'll hit in the next hour, and then we could
All right.
see what's happening. What about backups? Can we make sure that we aren't backing up the reads to S3?
I don't think there's a way to back up your read replicas, because there's no configuration for it, I would assume. But I have been very wrong so far today, so I'm gonna check. Maintenance and backups.
And how long are we
automatic backups disabled?
Okay.
Check the other one.
Yep. The next thing we could do is get this into Terraform. That way. Okay, fine. We won't do that. Why is the internet going so slow on me? There it goes. Okay, so notably read 2.
That one's still creating, I think.
Yeah, we should be able to see the... Yep, no backups there. Notably DB. I'm just going to close out all these. Maintenance and backups. So we have backups every 7 days.
Does that mean that these snapshots are kept forever?
No, I think these snapshots... So there's only 9 snapshots total. Yeah, so we keep 7 days worth of snapshots, and it looks like we do a snapshot between 8 and 9 UTC every day.
Okay. Great.
So you have a week to restore.
Yeah. This is
It should be
exciting.
safe to come out of maintenance mode now, right?
No, oh yeah, probably because these servers are both back up.
Which ones? Our primary is still modifying.
Is it? Oh yeah, never mind.
Oh, yeah. Good call. Do we need to make a pull request for the branch?
Yes, thank you. I was losing track of what I was up to.
No problem.
Okay, I see your note here, Z.
That is not the branch I wanted. Infra.
Where do I grab the URL from the second read replica?
It will be in your AWS console. You'll be able to go to one of your DB instances, and somewhere in here will... Oh, you might have to assemble it. You might need to copy paste what one of the existing one is, and then change the endpoint to the new endpoint. So like, oops, not that. Because I think all of the permissions are the same.
We could also do this after you stop your screen recording session. See, like we can have Jackson share his screen.
Yep. I mean, I can also just cut or overlay if we do decide we need to do it. Because no one's watching because we're not using we're not streaming it anymore.
Yeah, let's just do it after, and then it's one less thing to remember.
I need to figure out why this is mad at me.
Wait, what are you?
It like decided to mess up my branch. Push. There it is. That looks better to me. I think this is called haiku style. No, not really. All right, cool. So how about
next time we write the commit message as a limerick?
Yes, I'm on board for this. I want to just clean up my branches.
There once was a replica.
I'm loving this so far. Okay.
Sorry, Virginia doesn't scan, so we're just gonna have to move everything from Virginia to Ohio now.
What do you mean? Oh, Virginia can scan?
No, it doesn't. It doesn't scan for a limerick because there once was a replica in Ohio. There once was a replica in Virginia. Like it doesn't work.
So what if it's twas a replica in Virginia and all through the house?
No, now you're not a limerick, but we could still go. We could pick a different poem structure.
Fine. Okay.
It's fine because limericks are supposed to end with a surprise, and I'm not sure I want a surprise when doing infrastructure work.
So I want to. Yeah, right. I want to stop sharing my screen. Or sorry, I'm going to keep sharing my screen, but I'm going to blank out the next 5 or so minutes. But in order to tell what I want to block, I want to just do a clap so I can find it easy. So I'm just going to clap real quick, and then perfect. Thank you. That'll show up in my audio, super easy to find. And now I can comfortably open up the configuration and know that I will not expose anything. Where is the read?
Okay, it's still creating. But notably DB is available again. So
so that means we can Jackson can turn the thing back on.
And that's okay before we push the config?
I think it's fine.
Because it's just not going to route anything there.
Yeah, plus
Yeah.
the branch isn't merged, so it shouldn't. There's going to be
Cool.
extra stuff there, but no one's looking at it.
Okay. Maintenance mode is off. Should I put the worker back on?
Yeah, go for it. And now I realize I should have waited until it started before doing the kappa pasta, but whatever. I'm assuming that this is going to be named pretty similarly. And what did I say the name of that environment variable was going to be? Get that in Slack. Database read rec into secondary URL. Database read rec secondary.
You're on Cedar 14?
Yeah, we need to do. There is a bunch of stuff we need to do. just general housekeeping that we have not done yet.
That's fine. Like, it's not.
It's not.
It's not the prioritized thing. So
yeah,
it's not the thing that is preventing your business from functioning. So it makes sense.
Yeah, I'm gonna squash this and delete the branch.
Does that auto deploy?
Not to production.
Okay, good. Just checking.
Yeah, no, it goes staging and then to production. We could figure out. Okay,
that's fine.
And then meanwhile,
because I didn't see you set that Heroku config variable, and that would have been unhappy.
I have not been able to set it because the endpoint is waiting. I guess what small talk should we make while we wait for this system to provision?
Well, we're back up, and the quote that I opened to was my 5-year-old saying, "I just really wish my name had an X in it, like Parkix instead of Parker." Because X's, it's all the rage.
Wait, so does notably
things.
does notably
notably has to be Notablix soon.
Notablix.
Dumb question. Does notably allow kids to be like a member of the social network and post stuff to it, and it's up to the parents to manage who has access to that?
Not yet, but they're basically, the architecture is set up that way because kids are users. They're just inactive users.
I like this. I think that's a huge need because there's so many parents who want to like safely shepherd their kids to being able to interact on the internet, and the current systems just aren't designed for that. So,
absolutely.
Oh god, that is amazing. All right, come on, RDS. Oops, nope, that's notably DB. Notably DB read.
Are we still in the blocked out, Tom?
The blocked out what?
This will be the blocked out portion of the video.
Well, I was just gonna block out the 30 seconds or so where I showed the password.
Okay.
Why do you ask? I can also block out.
I'll save this for after.
Okay. Come on, go up. How long does it take to create something? Anyway, I guess we should look at the monitoring. So yeah, CPU utilization came up. DB connections are coming back online. Freeable memory goes down because we're bringing... Oh, because it's a smaller instance. Look at that. We still have 5, 6, 7 gigs freeable. It's mind-blowing. Mind-blowing. And then notably DB read. What are you looking like? Connections are back up. CPU utilization bumped up to something reasonable. Freeable memory is down, but still a ton is freeable.
Yeah, though we're not in peak hours.
Mm-hmm.
Yeah, I know. I just want us to just leap ahead and drop it down to like 2 gigs of RAM, because I think we can get there. We don't need as much iron as we have.
I think that's true, and I also wonder if you want to deal with the rest of the AWS bill sooner.
Yeah. I think there's some major S3 work to be done. Some cost savings there.
Okay. Fine. I mean, that is a reasonable thing to decide based upon business needs.
But also, related to that,
about it.
I think another priority might be if as soon as we could get that PDF rake task more performant and a couple other calls, then those would lower the spikes quite a bit, which we're kind of optimizing for the spikes here and not for the mean.
All right, I'm going to need to block out the next few seconds, so bippity 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 bippity. That'll make sure I understand exactly what to block. The bippity is an important part of my process. All right, so Control C, and then let's go to Heroku. And Jennifer, can you double check that I did a reasonable copy pasta job here?
I don't know what you did, so can you tell me what you did?
Yes. So the username and password are the same across all of the instances, but the endpoint is different, and the database name is the same. So this should be the endpoint. This CMJ1Y read 2 should be the same endpoint as shows up in the endpoint here. CMJ1Y.
Yes.
Yep, they look the same. All right. I'm going to add it. And I'm going to close this tab and delete it. And I'm going to bippity 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 bippity. Everything is okay. We can share the screen again. How exciting.
Open your eyes. Another villager is dead.
Werewolf style coding.
I wonder if moving from Heroku Cedar 14 to one of the more modern ones what kind of difference that would make, if any.
What are you referring to? What are the Cedar 14s?
If you go back to Heroku, I saw someplace that said that you were on the Cedar 14 stack, and that's a couple years old. I don't know if they still do much with it.
Yeah. What? So do you know what is entailed in upgrading that? Clicking the upgrade button.
I know it's basically click the upgrade button, but I don't know how risky it is.
Oh, it's only supported for another month.
It's pretty low risk in my experience. We could do staging first. We've got another 45 minutes. So we could do this on staging while we see how production goes. Does that feel safe to you, or you're like, oh god, this sounds terrifying?
That sounds fine to me.
I don't really know what we're talking about.
Oh, okay. So my understanding of this is super loose. Z, feel free to pop in and correct me. Heroku is going to install some base stuff, including the operating system, and they named that base stuff that they put on stack, and Cedar 14 is the name for one of those stacks that's a couple years out of date.
All right, we're back. Woo! Okay.
Yay!
So let's go back to Jennifer. Jennifer was explaining the different stacks and what those are.
Yeah. So my understanding of this is super loose. Heroku installs their software on top of AWS, and they call that software, which includes operating system and other stuff, a stack. And the stack that you're on is Cedar 14, and Cedar 14 is a couple years old, and it's based off an older version of Ubuntu. And that version of Ubuntu is either already at end of life or is beyond end of life, or maybe end of life is coming up. So that's why Heroku is saying, by the way, we're not going to be supporting this very soon.
Got it.
And it looks like we would need to do an upgrade of the Ruby version to at least 2.4.5 in order to upgrade to the latest Heroku Cedar stack, which I'm willing to give a
safe thing to do.
I think so. We have a bunch of really good tests, Jennifer. Infra upgrade Ruby to 2.6.
anytime you upgrade your operating system, right? Like, run your backups ahead of time. Probably
not.
everything will go just fine.
I have no fear. Fear is the mind killer. Really? RBN install list sudo apt.
Like, in theory, it should be possible to upgrade Ruby, deploy that, hit the upgrade button on Heroku, and everything works just fine.
How do you upgrade RBM?
Apt. Did you install it with apt-get?
No idea. Is it? Oh, it's just git pull. Okay, that makes sense. cd.plugins build. Again, there we go. All right, so we're installing Ruby 2.6.1. And we are going to update our gem file to say 2.6.1. And is there any other stuff that has 2.3.1 in here? Ruby version. So let's change that to 2.6.1. Great. This is going to be totally safe and healthy and amazing and awesome.
It should be.
It should be. Okay. Aha. Awesome. So is deploy is just gonna fail forever now because I clicked that button and now it's like you can't do that? Like I told it that I want to do an upgrade and now it's like forcing me to upgrade Ruby because I didn't realize that would force me to upgrade Ruby?
Oh, you're on staging. You're on staging. We're fine.
Yes. Sorry. Thank you for checking.
It's like, Jackson, don't touch production.
All right, so we've got 3 plates spinning right now. We have Ruby being installed. We have the
What are you
monitoring.
installing Ruby onto?
I'm installing it onto the virtual machine here.
Okay.
We've got monitoring, which is just kind of chilling. So read is cool beans. Read 2, whoops. Probably cool too. And then primary. Yeah, we bursted up our DB connections as the instances scaled, and then we fell back down. Our freeable memory is still pretty decent looking. It's starting to use a little bit of RAM, but not a ton. And our CPU utilization seems to still be kind of in a not terrible spot. Yeah, this is good.
But it's not actually using the Makura, right? Okay.
Yeah, so our database connections for read
DB2.
2.
For read 2.
Yeah, I expect that's going to stay 0 until we do another deploy. And because actually we can probably promote core. So I believe core staging, the deploy went out. Yeah, the deploy went out for the code changes. 4C903. Yeah, so we could promote read replica while we wait for Ruby to build. Does that sound good?
Do you want to like open it up? Just cursory open and
I don't know how to use staging. So Jackson, can you
open
staging? Yeah.
Yeah. Like see if it falls over as you look at it.
But like we haven't changed anything. That's just staging.
Yeah. Nothing should. Well, it's had fresh code deployed to it, so let's just satisfy my curiosity and open it up, see if it falls over. I don't expect it to fall over, but I feel like I would feel better checking it before clicking the button.
It's open. I'm seeing moments. Let me add one.
Water is amazing. All right, let's try and rebuild. The SSL package wasn't installed correctly, apparently. Or maybe it was, and I just don't know how to computer good. But hopefully this makes everything play nice.
So you're installing the new version of Ruby on the VPM so you can run the server, see if it falls over, and then push the changes up in a branch?
I'm going to push the changes up in a branch and rely on CI because I don't really know. So I have so much faith in past engineers at Notably just because the code is so like reasonable that I have trust that any of the cases that 2.6 would break would be detected. Because 2.5, right. 2.4, and 2.6 are all backwards compatible with 2.3. So unless we're doing something
it's not like
really
we're doing
weird,
a 1.8 to 1.9 or whatever.
Oh yeah. Ooh. Or a 1.9 to 2. Oh, I am really excited for Ruby 3. I am not excited for like a month of like going through all of my client projects and upgrading them and pushing it against CI and crying.
You know, I'm not too worried about that. I remember seeing Mats at a small talk in SF a few years ago, and we were talking about the next upgrade, and he was just so dead set on ever repeating the pain that he'd felt around 1.8 to 1.9. That was 1.8 to 1.9, right? That was
I think so, yeah.
Yeah, that I don't know. I just feel even with a major upgrade, I don't think anything will be that painful ever again.
Mm-hmm. So Jackson, how is staging? Is it
looking good?
Awesome.
I think we're good to go.
I'm gonna promote to production. Woo! Let's compare on GitHub first because I am a coward. Yeah, that looked good. And this name I think was copy pasted. Promote, and we can always roll back super easily by clicking the little.
I feel like
button.
Being double checking everything is not being a coward. It's being thorough.
Fine. All right, Jackson. Do you want to poke at core and see if core is playing nice? And hopefully DB read 2. I'm just gonna move it. So this tab is primary. This tab is read. This is read 2. And let's see our connections.
So what was promoted?
Being able to do read replica 2.
Okay.
So it's probably going to be hard for us to right now see traffic go to read replica 2.
No. Once all the instances come up, so like if we look at so we just did a deploy for Notably core. And where'd that deploy go? Well, let's go to the logs. Nope, set database. Yep, so this got set. This is fine. There's the deploy. So the deploy just went out, and I expect that we're going to start seeing traffic start going to this deployed instance over the next couple of seconds. And we should start seeing connections being made. Yeah, one connection. That's exciting. And
Yeah, but wait, why would it hit read 2?
Because we have it configured to hit read 1 and read 2.
Why wouldn't it hit read 1 only?
Because it's not a failover, it is a simultaneous read replica.
It's like redirecting, is that right?
It's a fan out, not a failover.
Yeah,
so,
that makes sense to me.
I mean, that's my understanding. I could be completely wrong here. The other thing is Makara is configured for connections to be sticky, so it's not going to try and connect to this second replica until another connection is requested. So right now we're at 21 connections for read, and my expectation is that should stay pretty stable, and then we should just see more more connections go to read to over time, and it should start to stabilize that metric. Because I think we're hoping to get like 20-ish connections per replica here. What am I doing with my life?
Go back to the VPM and see if Ruby finished installing, and then
right.
and then and then trust the CI.
Oh, no. Gem uninstall bundler. So install bundler -v 1.17. So have you seen this yet? Where if you accidentally
This
push
feels
up,
very familiar, and I don't know why.
so Bundler 2 is not backwards compatible with Bundler 1, and a lot of the infrastructure hasn't moved to Bundler 2 yet. Do we have a circle.yaml? Yeah, we do. Huh. Interesting. CI might get really mad at us here. Git commit grade to Ruby 2 in preparation for Cedar deprecation.
2.6.
Yes.
And we were going from what, 2.1?
All right. I'm going to call this prepare for.
It's great.
Cedar 14 is deprecated, and Heroku 18 mandates 2.5 plus. So we upgraded from 2.3 to 2.6 for future, so we don't get left behind again. And I'm willing to bet Circle CI is going to be very mad at us because I don't think we're not using their new syntax. Whoopsies. I need to go to here. There we go. And if we're not using their new syntax, they might not allow us to build Ruby 2.6. Or they might. Oh, look it. We got 20 connections. Look at that. Beautiful. Look at how much freeable memory we have. We could totally cut these in half again.
But
Next
maybe
time.
later.
Fine. All right, so
In order to reduce those, would we need to make changes to Makara config?
No.
Or could we could just go into maintenance mode, change the size, instance size, and go with it?
just like
it
we
wouldn't-
did.
Instance type.
It wouldn't, as long as it doesn't try to rename your instance.
It doesn't. That would be a horrible design. Whoops.
It would be, but
Nope, that's not you. You're notably. Sorry, everyone.
do you need some clapping?
Nope, it's fine. I think it was just a list of all of my clients, which I need to, put on my website anyway, or our website anyway. Yeah, it looks like it's actually installing Ruby 2.6. So never mind. My fears are abated.
Does this happen without any downtime?
Yes. Yeah, so Heroku has a gradated deployment strategy where when you deploy a new version, it waits for that server to fall over, or it waits for that, it basically deploys it and then puts it into the mix, and then once that server has started accepting traffic, it will turn off the old servers.
Cool. That's why we pay them the big bucks.
I mean, AWS is a pretty solid replacement for Heroku right now that is way cheaper, but it's not as convenient. So I'm a convenience-aholic, so I'm more than happy to keep paying Heroku. But I'm learning about that because another one of my clients uses Elastic something or other. I don't remember the name of it, but that's how it It's basically their Heroku replacement, but it's all programmatic instead of user interface driven. It's not Elastic Beanstalk. Maybe it is. It's Elastic Container Service, maybe?
I can't keep track of the Amazon services.
Yeah. ECS, Containerized Applications in Production. So you can deploy your stuff as long as you're using Docker or another containerization system, and it will handle the routing and rerouting and scheduling and all that crap.
Which
and then,
means instead of paying Heroku to make it easy, you now need to pay some engineer, your team or otherwise, to do the Docker work.
yes and no. So there are services built on top of this where you can basically there's services that are what is the name of HashiCorp? HashiCorp has I believe it's Nomad, which allows you to manage. Yeah, it allows you to do the Heroku-y style thing across multiple cloud providers. So AWS, DigitalOcean, all that stuff. And it makes your operation super, super easy because you do the rolling deploys, blue-green, failover, all that stuff.
Yeah, you're still paying someone someplace. Nothing's for free.
Yes, you are definitely paying someone something in some place.
And adding complexity.
Or shifting complexity out of Heroku and into your organization, right?
Mm-hmm.
So I am a big fan of Heroku. I'm not advocating that Notably moves off of this, but for managing your RDS instances, we would want to think about using something like Terraform for so that, because right now it's all just like through the UI, and we want to think about how we do the provisioning of your servers in a programmatic way so you don't have to worry about accidentally clicking the wrong button or whatever. And that's what Terraform does. It's pretty cool.
How fast does the test suite run? Do you think it's done yet?
No, it's not done. It's going to take a little while, especially because it's doing the 2.6.
Oh wait, estimate. What's the estimate? Top of screen. Keep going all the way to the top. There it is.
Sorry, when you say top of screen, I think you mean up here.
Yeah. So it's not very. 3 minutes.
So yeah, but that's because it's installing Ruby, and that's way behind. Oops, it failed. Cool. What is stub socket? OAuth request spec. Oof. Okay, I don't think we're going to be able to get to this today.
OAuth, if that is related to like a Facebook login, which we deprecated years ago.
I'm not super keen on trying to push forward something with this many failing tests in the next few minutes. What I am keen on is using this for our next session to figure out, because like the risk that you're running into right now, it's March 1st. You've got a month and a half before you have to move off of Cedar and onto Heroku 18. So I think we've only got like 50 errors here, and all of them are likely related to libraries that are now 2.6 compatible, but I am terrified of doing it in the next 10 minutes or so.
Yep. Makes sense.
So yeah, how do we feel about where we're at?
The only thing to note is now staging is set to try to go to Heroku 18.
Yeah, so we can't do any deploys to staging until we finish this work. Because I didn't realize it was going to block us, and like there might be a way to tell it to not do the upgrade, because that is mind-blowing that they're like being such a butt about this.
Wait, you're okay. You're on Notably Core, not staging.
I am on staging.
Okay.
No, I don't want this anymore. Undo. Stupid computers.
It's fine. He just can not deploy staging until.
Yeah. Anyway, I think we're good. I think we're done. We've got the database accepting connections for read. We've got, 20 so odd connections for read 1, 20 so odd connections for read 2. CPU utilization doesn't seem terrible.
Yeah, in any minute that rig task should run.
All right.
Cool. I will keep you all posted on how it looks throughout the evening.
It's awesome.
And then, Z, if you could help me kind of write up some of those next steps, just so I make sure I'm not missing anything on loose ends, that would be super helpful.
Yeah, let's. I'm gonna stop recording and then let's talk about that, and also put stuff into your notably development channel.
Perfect.